Alright guys, lesson 4, organic reactions. So we're going to look at the various types of organic reactions. Alright, so our first reaction is combustion. So this is when an organic compound reacts with oxygen to produce carbon dioxide and water. Okay, so it's always going to be a reaction between a hydrocarbon and oxygen, and then you're always going to end up with carbon dioxide and hydrogen and water as the end. So one of the tricks we're going to do for this is when we balance these equations. The idea is you balance the carbons first, then the hydrogens, and then the oxygens. It just makes it a little bit easier for you as you go through it. So let's look at an example. All right, so let's look at our example. So we're going to have C3H8 plus oxygen yields carbon dioxide plus water. So I'm just going to already quickly balance this. So we're going to have 5 oxygens here, 3 carbon dioxides there, and 4 waters there. And everybody should be happy on that end. So just something to note, if not enough oxygen is present, carbon monoxide is formed, and it's not a true combustion reaction. Okay, so again, it is the reaction between a hydrocarbon and oxygen, and we're always going to end up with carbon dioxide and water, as well as heat. This is an exothermic reaction. Okay, so that's our first reaction. That's combustion. Our next reaction is going to be substitution. So this is the replacement. The replacement of a hydrogen atom by a halogen. Remember our halides? This is how our halides form. Hydrogen atom by a halogen. It is always in a saturated hydrocarbon, so no alkenes or alkynes. It's going to be with alkanes. Always uses a saturated hydrocarbon. And let's look at our example. We're going to look at the example between ethane reacting with bromine. And this is going to give us bromoethane and hydrogen, I didn't leave myself enough room, hydrogen monobromide. So let's look at these. So ethane, C2H6, I'm not going to draw my H's for sake of time, plus bromine. Remember that bromine is a diatomic, so it's going to be Br2, so I'm going to draw it like that. And then we get bromoethane as a product. So we have start with our ethane, and then we're going to add on our bromine here. And then our final product is hydrogen monobromide, which is HBr. So what we notice here is that a hydrogen here, right? Those are our hydrogens. Swoops over and is replaced with the bromine. So they just flip-flop, they switch, they substitute with one another. Okay, so this is how we get our halides. So let's look at an addition reaction. So this is 2 things coming together to form one thing, right? So atoms are combined with an unsaturated hydrocarbon. So these are our alkenes and our alkynes. So they're combined with an unsaturated hydrocarbon. So these are our double and triple bonded hydrocarbons. Not hydrogen carbon, hydrocarbon. Okay, so it is 2 reactants, 1 product. So let's look at the example of ethene and chlorine. Again, this is now going to give us a halide, one of our functional groups. We're going to end up with dichloroethane. So the reason why it's di, if you remember, chlorine is Hofbrinkel or Brinkelhof, so there's going to be 2 of them there. Okay? And the reason why this is important to note is that we are ending up with just one product. So it's not a substitution like before where we'd only be taking one chlorine. We're actually taking both chlorines. So let's look at it this way. So we have our ethene with our double bonded carbons, right? We're adding this to Cl2. And we're ending up with our dichloroethane. Okay, so the switching that had happened here, we have our double bond breaks, and our bond here breaks. Our first chlorine swoops in and attaches here, and our second chlorine swoops in and attaches there to fill in those places. So again, this is 2 reactants and only 1 product. Let me change that so it looks clearly like a 1, and only 1 product. So a little bit different than substitution. This is addition. Remember, A plus B gives us AB. All right, so that's addition. Let's look at esterification. So this is how, you bet it, you guessed it, we get our esters, right? So this is when an acid reacts with an alcohol, and we get an ester and water. So let's look at our example here. We're going to do ethanoic acid. And we're going to add that to ethanol. And our product is going to be ethyl ethanoate. I am having a very hard time spelling right now. Ethyl ethanoate. There we go. So this gives us our parent chain. And this gives us our alkyl group. So let's draw out our structure so we can see this. So let's look at our ethanoic acid. So we have our carbons, which is 2, our hydrogens here, and our acid again is the double bonded oxygen with a hydroxyl group. Okay, we are going to add this to ethanol, which is our alcohol. So 2 carbons with that OH, and everybody else's happy H's in here. And we end up with our ethyl. So we're going to have our ethyl group here, the oxygen that sits in the middle, then we have our ethanoate here. So we're going to do this guy here. We're going to put our double bonded oxygen there and our end. So we should end up with this crazy looking guy, but this is our ester. Okay, so what happened was, excuse me, this hydrogen and this OH group formed our water. And then the bonds that were left brought together our whole ester here. So that's esterification. So this is your generic breakdown of the formula. So it's an acid, remember the functional group here, plus an alcohol, our OH functional group, and we get our ester with this being the functional group, plus water as a product. So saponification. So yes, this is the production of soap. So it is a fat combined with some kind of base, and it gives us an alcohol and soap. Okay, so some of our bases here, we're going to have NaOH, could be something, potassium hydroxide, magnesium hydroxide, calcium hydroxide. So any of these guys, lithium hydroxide. So remember, hydroxides give us our bases. We're going to talk about bases and acids in a future unit, but these are just some of the key ones we're looking at. It's a metal plus an OH group. Right, we're going to end up with an alcohol, and then the remaining compound is going to be soap. We don't need to know the full formula for this, just know this setup here. So fat plus a base gives us an alcohol plus soap. Okay, next, so we have two more we're going to talk about briefly. So fermentation. So I'm sure you guys have heard of this before, especially back in biology. So this is the breakdown of a sugar into an alcohol and carbon dioxide. Okay, so let's look at our prime example of glucose. So C6H12O6 reacts with some kind of catalyst. And then this is going to give us our alcohol plus our carbon dioxide. And then I'm just going to go in and balance everybody here. Here we go. This is our alcohol group. This is our carbon dioxide product, and this is our sugar. Right, so we can have different sugars reacting to form different alcohols, but we're always going to have some kind of an alcohol as our product, as well as carbon dioxide. All right, one more reaction we're going to talk about. So this is polymerization. So this is how we get polymers. So whether they're synthetic or natural, so plastics or amino acids. So it's the joining of a monomer. So this is an individual hydrocarbon. To make of monomers to make a long carbon chain. Okay, so we have natural polymers. Like I said before briefly, these are amino acids, cellulose in plants. And then we also have our synthetic ones. Synthetic. And these are plastics, nylon, rubber, different kinds of products you probably work with and deal with every single day. Okay, so in addition, polymerization, so we're just going to do this very briefly. So N, I'll explain what N is in a second. So CXHY, so this is your hydrocarbon or your monomer. And then we are going to end up with a longer chain of them. So N is equal to a very large number. And this is going to be addition polymerization. You can see an example up top here. So we have 3 different, and then even more the ... So we have multiple hydrocarbons coming together to form a large chain of these. And then we also have a type of polymerization called condensation polymerization. I'm going to open a blank slide to write this on since I ran out of room on this page. So we're going to do condensation polymerization. Again, these are just concepts that you need to be familiar with and need to know. We're not going to be looking at a lot of these crazy reactions. But condensation polymerization is when we remove a hydroxyl group from a monomer like acids or alcohols, because those are where our hydroxyl groups are found. And we end up, so we produce polymer and water as our products. Okay, so just two different examples of polymerization. That's the end of our types of reactions. So again, you guys don't need to know exactly how these reactions all play out. Just be familiar with the different types of reactions. So we'll make another slide, we'll make a brief list. So we had combustion. It's always going to be a hydrocarbon plus oxygen, and we're always going to have carbon dioxide plus water. Okay, so that's combustion. This is an important one. Substitution. This is when a halogen comes in. So we're going to have a hydrocarbon plus a halogen, and we're going to get a halide plus usually an acid. Okay, we're going to have addition. So this is a hydrocarbon plus a halogen, and we just get a halide, right? So our formula is A plus B gives us AB. This goes back to just a regular simple type of addition reaction. The only difference now is we're working with organic compounds. Next, we have esterification. And this is an acid plus an alcohol gives us an ester and water. Next, we have saponification. So this is the formation of soap. This is like a little review summary of each reaction for you guys. So produces soap. And our formula is fat plus base gives alcohol plus soap. Right, and then we had fermentation. And this is sugar plus a catalyst of some sorts, and this gives us an alcohol and CO2. So this is the breakdown of sugar. Okay, and then I will open one more slide just to recap polymerization. And then our last one, polymerization. So this is a monomer plus a monomer plus another one. So plus multiple ones. And then it's going to give us this long carbon chain. And so they're all going to come together for these long chains. The amount of monomers that are added together, it could be quite large. So just know that this one, and again, remember monomers are our hydrocarbons. Right, so it's just many different hydrocarbons coming together to form a much larger carbon chain. Alrighty, guys. So that is our reactions. I will see if I have a supplemental video, like a second video that kind of shows maybe them in action for you guys to take a peek at. Make sure you do the Google form assignment that is posted in Google Classroom. These are counting as assignments, not quizzes or anything. And I will also get a Castle Learning of Organic Chem posted for you guys to look at. And I'm also in the process of looking for like a more fun activity that you guys would be able to do at home, either on the computer or with just everyday stuff that could be in your cabinets. But I will get in touch with you guys about that soon. Again, stay well. Make sure you're doing your work, not just for my class, but for everyone's class. If you have any questions, you guys know how to contact me. Good luck.